Hey guys, welcome to Trends in the Periodic Table. So exciting. Let's explore it a little bit, shall we? Alright, so here's a periodic table. The first thing we want to talk about are families and groups, same thing, and periods. So a family or a group is simply going to be a vertical arrangement. Okay? So this right here is a family. Okay? And this particular family is a family called the noble gases, from helium all the way down to radon. And we call them the noble gases and we call them a family because they all behave chemically very similarly. They don't like to form bonds with anybody else because they have full happy electron shells, electron energy levels. And so we call them the noble gases. Okay. We also have, for example, another one over here on the other side. This group here, and by the way, family and group are oftentimes interchangeable. These are the alkali metals, extremely reactive. Okay, they have one extra electron hanging about that they like to get rid of. Another family name that we have is this one here. These guys are the halogens. They're also extremely reactive because they have one hole that they would like to fill with an electron. Okay, remember that we see in the halogens you see chlorine, and in the alkali metals you see sodium. Remember when we talked about how sodium and chlorine get together, that's why they are so reactive. As a matter of fact, if you do put sodium and chlorine together, it's almost explosive. Okay, and we have another one here, so right next to the alkali metals, not quite as reactive but still pretty reactive, are the alkali earth metals, all right, and they all behave the same way. All right, so not every one of these has a nice name like that, but one thing they do have is they do have numbers. So these particular, all right, change this here, these particular periods, or it's not periods, but groups or families have numbers. The first one is 1, 2, and we're going to skip all these guys in the middle. These guys here are called the transition. And for reasons that will become later, we're going to skip them, and don't worry about them, and just skip over here to 3, 4, 5, 6, 7, 8. So these are 1 through 8 in terms of the numbers that are associated with these families or groups. Okay, and we skip the transitions. Okay, now remember, we're going to be spending our time in the first 3 periods. Now, periods are the horizontal rows. Okay, so if I'm going to use yellow to indicate a period, this here, lithium, beryllium, and all through over here would be a period. Okay, it's period number 2 because it's the second one down. From sodium, starting with sodium and going across, this would be period number 3, going all the way over to argon because it's the 3rd row down. So we're going to be spending and look at this, the period up here, this first one, period 2 just has, or period 1 just has 2 elements in it, hydrogen and helium. So these are the 3 periods. Periods are horizontal and groups are vertical. Okay, and the thing about periods is we know that as you go across a period, the characteristics of the atoms, their chemical and properties, number of electrons that they have and such, changes in a predictable fashion. Okay, and the periods, that's how that works. And then the families or groups, every element in that particular family or group is very similar or behaves almost identically chemically. Okay? Okay, so here's our nice clean periodic table again. So we've described some of the groups or families. One thing to pay close attention to is if you know that this is the, let's say for example, if I look at boron, element number 5, that's in the 3rd period. Okay, that means it's going to have 3 electrons, okay, in its shell. Okay, 3 electrons in the shell. Carbon is group 4, so it's going to have 4 electrons in its outer energy level. Okay, nitrogen is group 5, so it's going to have 5 electrons in its outer energy level. So even though nitrogen is element number 7, okay, watch what happens. Let me diagram nitrogen right here for you so we can see how this works. Okay, so here's nitrogen. and in the first energy level, it's got 1, 2, okay? And in the second energy level, remember, nitrogen is element number 7. In order to be neutral, it has to have the same number of electrons as it does protons, which means 7. So notice, it's got 2 in the first energy level, which leaves 5 for the second energy level. 1, 2, 3, 4, and 5. So in its outer energy level, it's got 5. And notice that corresponds with the number, okay, of its family. So it's family number 5, okay, and it has 5 electrons in its outer energy level. Look at here at fluorine. Fluorine, okay, is in the family number 7. How many electrons would it have in its outer energy level? If you said 7 electrons, you are correct. It's element 9, so we'll have 2 electrons in the first energy level, and then 7 in the second energy level to make 9 electrons total. So the number of the family is also the number of the electrons in the outer energy level. And again, we are not going to worry about the transition zone. These are all those transition elements here. We're not worrying about them right now. We will come back to them at perhaps another time. You do 1, 2, skip all through the transitions, and then over to 3, 4, 5, 6, 7, and 8. Right? So those are the trends in the periodic table for starters.